This is a microwave that I found on the side of the road. I would have expected that this was potentially even a brand new microwave, because when you open it up, you can see that it's actually really clean. But if you take a look inside, you can zoom in and see that this was manufactured in February of 2006. But without seeing that, otherwise, this looks like a very new machine. So the first thing that we want to do is take the stuff out of it so that it doesn't start flopping around on us as we move a little bit through our exercise. The next thing we're going to do. The stuff that we want out of the machine is right here. So we start where the power comes in, and this is a filter that filters out the RF noise that's generated by the microwave. Right below it, we've got an AC powered fan that's used to cool the unit. Right here we've got the large capacitor. This is where you really have to be careful and make sure that the capacitor is discharged if it has been powered up recently. Right here we've got the transformer. This is the transformer that takes the 120 volt power and steps it up to around 2100 volts for firing the magnetron, which is here. The magnetron has the nice big magnets that we'll be harvesting out a little bit further along the way, and is really where the business of the microwave is done.
Does this use nuclear energy?
This does not use nuclear energy.
I think the dog disagrees.
Well, he's a dog. I guess that's some type of motor. It looks almost identical to the motor that you'd expect to see on the bottom for spinning the turntable. And to get to that, we're going to have to take this other piece out. So on other units, it's sometimes easier to get to. Right along here, you've got some temperature cutouts for safety that will kill the power if the unit gets too hot. And then right here, you've got the control board, you've got the low voltage transformer, and the PCB that's got, it looks like some lytic capacitors. We've got a piezo, a couple of relays, and then over along here, you've got your safety switches that are used to keep the unit from powering up if you've got the door open. So having said all that, I typically start at the back where the power comes in and start disassembling from there. And I'm not going to be needing these screws for representing the microwave back to the streets. So I'm not too worried about that. And coming into this, we've got wires tied off. That's not, so I can kind of get these out of the way. This is the power leg coming in. When not successful by hand, we use our friendly needle nose pliers.
How do you know you're not going to get shocked?
Well, I'm not touching anything that's conductive, is probably the easiest thing for me to start with. This may be a little bit easier if I cut this zip tie off that's helping to bundle the wires, so that I can get around them a little bit, move out of the way, so that I can grab the power lead and pull it out. And now I just need to pull my neutral lead out.
Can't see.
And now I have salvaged a perfectly usable US type plug that I can use for powering something else in the future. Many things are possible there.
Wow.
So now we're back to the filter that I mentioned before. So this is on a real small PCB, so we will just pull that loose. And in order to get it out, there is a neutral and a hot connection that feeds the rest of the fuse.
Testing for continuity across.
Yeah.
fuse.
So for
You're
better,
using your Voltotron.
I am using a digital multimeter
Very good.
and testing for continuity. And so a better test is to actually pull the fuse out. And yep, I've got continuity across it. So that is salvaged. And I will take the stuff that I usually am going to keep and kind of put it to the side. So working backwards with the wiring, because when this is done, I will have planned to have stripped out all electrical components, all wiring. Really the only thing that will be left that I will return to its original home in the main streets is any plastic and sheet metal that form the shell of the microwave, but effectively all the guts to the unit.
I see what you're doing.
So I am testing for continuity across it. So I have no reason to believe yet that this microwave was not good. So what I have found in some of my finds is that a simple part like this will have failed, and that will keep power off to the rest of the unit. So that would make somebody that wasn't extremely knowledgeable about these units and the way that they operate believe that they needed to replace their microwave. So we'll save that in case we ever wanted to repair a microwave. I don't really see that from the manufacturer, at least. So right here we've got a small little motor. This says that it takes 21 volts. It's a 3-watt motor. It will spin at
4,000
apparently between
RPM.
29.1 and 34.9 RPM. Maybe you could use this for some type of robotic project. I don't know. It's a motor. No reason to believe that it doesn't work. So again, into the treasure pile it shall go.
Made in Korea. Is that common?
So here we've got just a loose connection that we pulled both ends of it off, and we'll save that for possibly connecting up something in the future. Assume that something is powered, so we're going to work very carefully and not touch any of those live conductors directly. So we'll pull this safety sheath out of the way, and we will pull out, or attempt to pull out, each of the connections into the capacitor. So the first one's out, and this is one coming from the magnetron. And this one right here is coming off of the transformer. And so now that we've disconnected that, all we need to do to make sure that this is really safe is to make sure that that capacitor is drained. What most of the other videos that you see will tell you is to place a resistor across it.
Are you excited?
Not especially.
I'm really excited.
So this is a microwave oven, so there's only so much excitement to be had. So we will go ahead and take off this resistor diode or whatever it is. And let's see. Okay. So this capacitor is held in, it would seem, by...
Can't see with the rig now.
Yeah, well, I can't see what's going on inside the microwave.
There we go.
Let's see. Maybe easier to take this entire fan assembly out. So back on the back of the unit, we'll see that we've got a couple more screws.
Where's the capacitor?
This is the capacitor right here. So capacitor for microwave oven, 2100 volts, 1.05 microfarad. You know, I can't remember if the mu is micro or pico. And you're gonna have to fix that.
We'll edit that out.
Yep. So we will unscrew this bracket that kind of holds the capacitor in. And get that out of the way. And now we've got our capacitor. So just for fun, we will test the capacitance of this bad boy to figure out if possibly this could have been why someone so cruelly threw this microwave to the main streets. So we will set our meter into capacitance mode. And that's irritating. And apply our meter.
I can't see. What are you touching?
So I am touching each leg of the capacitor. And for a second, I thought I saw. Try this again.
What are the legs?
For a second, I thought I saw.
Inside these black tubes here?
Yeah. So you can see that the terminals are down inside there. And so the reason those are there is, again, for protection, so that
It's like a condom.
you have to go out of your way to touch that. So I'm going to apply my test leads from my meter, one to each side, and there, as you will see, I am picking up 1.08 microfarads, and this is a 1.05 microfarad capacitor, plus or minus 3%, so I think we're well within range there. So it's safe to say that this is a good capacitor. What we'll go ahead and do is use our needle nose pliers to pull that diode or resistor or whatever that is out of this bad boy.
We'll edit that part.
Yep. So I'm just grabbing him and pulling him out, and now I've got a capacitor that I could use again for a number of applications, but really something this big is probably best in a microwave. More treasures for our stack. Now let's move to the fan that's inside the fan assembly here. So this is for cooling the unit, so this just vents out the back. So we will pull the connections off of the fan. And now we've got to unhook the motor from the plastic, because we are environmentally conscious and we want to return the plastic to the main streets. So what we can see right here is that these screws right here are what is attaching the motor to the plastic. As such, and now we've got a piece of plastic that is not of use to us,
Going back to the
as well as this little guard over the terminals for the motor, so we'll throw that along, but we will put the fan blade back on the shaft.
Shaft.
And let's see. Yeah, nothing special about this one. This one was just pressed on. And now we've got another little motor that we could use for another excessive force to get that apart. Now this is still connected to the very nice.
We'll have that.
Solid. Now that looks a little bit corroded. I have not seen one that looked that corroded. So
Would that be because it was left out in the mean streets?
I don't know. I don't think that this was left out that long. But in addition to that, this is pretty well protected within the unit. And if you look at, say, the PCB as an example, that looks pretty clean. So
There's the PCB?
Right there. Printed circuit board. So I haven't seen anything else in this unit that would lead me to believe that that was water damaged. But you remember the two magnets that I mentioned earlier? That's one of them and that's the other one. And so these are always fun and require a little bit of excessive force to get that apart. Now this is still connected to the very nice.
We'll have that.
Solid 9.0.
Yeah.
These are also still connected to the secondary windings on the transformer, so we'll go ahead and pull those out.
I can't see with their big manly arm.
There. So now the magnetron is free. So despite the fact that this says danger, high voltage microwave radiation, there's actually nothing in this box. It's not hermetically sealed or anything like that. It's just a couple of coils that are fairly small and not super remarkable, but I'm guessing that with 2100 volts passing through it, there's a reason why they make it very difficult to get inside. But we're going to put this to the side.
She ain't easy.
We're going to put that to the side and come back to that. So what you can see right here is the microwave, the magnet. So the next thing that we're going to do is I'm going to save the transformer and pulling that out for last because that's going to require us to flip the unit upside down. There's some screws that are attaching it to the bottom. One thing for anybody who doesn't know, microwaves are not very heavy except for that transformer. So all of the weight, or a large part of the weight that you feel when you pick up a microwave oven, is really tied into this transformer.
How much of it?
I don't know, 75%.
That's big.
I don't know. If you want to be scientific about it, I guess we could weigh the stuff out.
We don't have a scale.
Nonetheless, I'll go ahead and pull the leads off of that. And so the next thing that I'm going to do is really just try to pull all of these connections out. So this connection is going into one of the switches that's associated with the door. And I don't know exactly what all of these switches do, but my understanding is that they are for safety to make sure that that door is closed before the magnetron gets energized. So I'll pull out these at the bottom, and then we've got this one right here. But again, this is consistent across all the microwaves that I have salvaged, there's 3 of these switches, always in this little plastic enclosure. Now this one is a little bit different in that the plastic that's connecting basically both leads, they're going into that switch. Those are connected together. That is a little bit different from what I've seen, but you know, no big deal.
Is that magnetic?
No.
Oh. Why is it like pasta?
Was it what?
It's like a pasta.
Because there's several of them, several.
Oh.
So we'll go ahead and pull off all of these other connections. Here we've got a larger connection that's got, and then the last part there is another screwed in earth connection. And we will unscrew that, free that.
Be free.
And the last 2 wires that are tied up in this thing are coming from the turntable motor that is underneath the unit. And so we're going to see if we can get all of these disconnected, but more than likely they're going to a couple different places within this, a bunch of these wires. So I'm just going to leave that to the side and leave that hanging there. And we'll save all of the stuff that we're going to have to deal with underneath the unit for the here we've got an envelope up here on the top that says imported. Do not remove envelope or destroy contents.
Oh, open it up.
And it says replace contents in envelope. So either there's a secret treasure here, or it might be the wiring diagram, service and parts information, which is actually what the envelope says. Nonetheless, we're going to help our fellow savages that may be trying to salvage this microwave really for the scrap. A lot of times these switches, a lot of times they're harder to get out than that, but that one actually came out pretty easily. So this switch has a common connection, and despite the fact that it shows a normally closed and normally open terminal, the only one that's here is the normally open terminal. So this switch is going to close based upon pressing the button. And so we'll put that aside, use that for something in the future. This switch right here, it looks like, should be able to push that plastic out of the way and pop this puppy out. Okay. And so I thought it was going to be easier to get that one out, but I think...
Try that, please.
I'm thinking looking at this guy, it's going to be easier to take the whole door assembly thing off in order to get the PCB later anyway. So I'm going to go ahead and do that. Switches that I have yet to pull out. So let's see. I'm gonna, you know what? The door handle will continue to work. It won't break that, so I'm not too worried about that. So we'll grab that and grab that. And I'm really not sure how they get these things in here. When they put them in originally, but there, now we've got that switch out. And so this switch also, like the first switch, has both normally closed and normally open contacts labeled on the switch, but there's only a normally closed contact. you would press this button to break continuity across that switch. And what's interesting about that is that if you notice, it has a green switch, whereas the other one had a red switch. And this last one that I'm about to pull out also has a red switch. And I'm gonna go out ahead and guess that this one is a normally open one, like the original one that we did. And so we're just holding this guy in place. Okay, so it's this piece of plastic right here. Both of our switches off, and so yes, this one does have only a normally open and common connection.
You were right.
3 switches harvested. So the next thing what we've got to do is figure out how to get the PCB and basically the unit controls off. And so in looking at it, it looks like it is secured into the unit by another piece that is secured onto the chassis of the unit with this screw right here. So I'm going to pop that off and then see if that gets us anywhere. Whoopsie daisy. And this transformer does not fail to disappoint as far as size goes.
Oh.
Hot camera girl, you want to hold this and tell me how much you think this weighs?
Oh no, I can't. Oh.
Yeah, so this is not light.
No, that's not. You make
really are strongly advised against dropping this on your foot.
Yeah.
You're gonna not enjoy your day if you do that.
You could really.
We do know that there is a motor underneath here that is used for spinning the turntable. It would seem that the way to get that out is to remove this piece right here. First screw that I took off must have been landing right here and was really just used to secure the cover, not necessarily to secure the motor to the microwave, because that is actually accomplished by these 2 screws. Nonetheless, we'll go ahead and pull the wiring off, and that is the last piece to the big bundle of wires that that's the motor for the turntable that we've also salvaged. So that's all fine and good. There's nothing else exciting here to see on the bottom of the unit. So having said that, we'll go ahead and put its clothes back on.
Ooh, so soon.
Yep, very soon. So number one is to well, number one is going to be to get this PCB out. And number two is going to be to get the temperature humidity sensor that's apparently on the other side of the unit off. So let's take a quick peek and figure out what's holding this in place. Okay, here and here. And it looks like the door handle may be part of our issue here, so we have to figure out how that comes off, or how it gets reattached, because again, we really want to, there we go. It just slides on out. So what you'll see on the front are all the buttons, and then on the back, we've got the PCB. And so up here at the very top, you'll see all of the connections that are going down to take the input from the buttons. And in addition to that, we've got this ribbon cable that's going back around as well. So the first thing that we will do is take this PCB out. This PCB looks like, it looks like these screws right here are doubling to hold the low voltage transformer in place, as well as to hold the PCB in place. So we'll pull those out. I'm not too interested in chasing after these buttons. I think it's gonna, it looks like it's gonna be difficult to get those out.
The boy feels differently.
And in a way that we can put this back to look as if nothing happened to it. So I may just, there we go. Okay, it pulls out. And so now we've got this LG Electronics processor that looks like that's the brain behind the operation, despite the fact that this was a GE unit. So we've got a few diodes here. We've got a couple of other components, a couple of relays. Number of devices that might be worth pulling off, and then we've got this display. Taking that out. So now what we want to do is start thinking about, well, we've got the last step of taking off that temperature and humidity sensor on the opposite side of the unit. So we'll do that real quick. Exactly nothing. So this is vented into the internal, I guess the cooking chamber of the unit, and this is that temperature and humidity sensor that I mentioned earlier from the schematic. So that is held onto this piece of metal with this piece right here, and we will just unscrew that, take that out. Is that bent in there like that? Nope, there we go. Okay, so we've got that piece out, and now for simplicity, we're just gonna put this piece right back where we found it. And that concludes everything that we're trying to take out of the unit. But this is where the real fun begins. looking lightweight microwave oven.
Wow.
So it is much lighter physically because it's missing the transformer that, as I mentioned before, is super heavy. It's also light in regards to the fact that, well, it really doesn't have any functional components left. But no job is completed without replacing the turntable. And a cover plate that was apparently included with it. And if you look around at the outside of the unit, minus the fact that it's really lightweight for its size, and there is no power cord, otherwise, no one would be any wiser that this was not a fully functional, beautifully well cared for GE microwave with a beautiful stainless steel finish.
Well done, Dr. Good.